Hello everyone. I am Wentao, a master's student from Anhui University in China. I am very happy to share our paper published in AI 2024 with you today. The title of our paper is Structural Information Guided Multimodal Pre-Training for Vehicle-centric Perception. We will describe our paper in the following 5 parts. The first part is the background introduction. With the development of artificial intelligence, vehicle-centric perception issues have received increasing attention, especially in the fields of autonomous driving, security monitoring, and smart cities. Many computer vision problems have been proposed for vehicles, including vehicle detection and tracking, segmentation, attribute recognition, re-recognition, fine-grained classification, and partial segmentation. Currently, the main challenge of vehicle-centric pre-training tasks is that general pre-training methods result in suboptimal performance on vehicle problems, and there is a lack of large-scale vehicle pre-training datasets. Therefore, we first collected a large-scale vehicle dataset called Autobot1M, which includes 1,026,394 image data and 12,693 text data. These image data come from different scenes and sources, including 732,112 surveillance perspective images and 294,282 network scene images. These images fully reflect the key features of vehicles, such as lighting, motion blur, viewpoint, and occlusion. Our dataset also considers multiple challenging factors, such as lighting, motion blur, viewpoint, and occlusion. Vehicles usually have some obvious visual characteristics, such as their contours are usually composed of lines and curves, and their colors are consistent. These characteristics are different from those of ordinary objects. We believe that these characteristics can be utilized in the pre-training stage of the model to enhance the model's ability to perceive the visual structure and form of vehicles. Therefore, we introduce a structural prior module to extract the vehicle contour through the contour extractor, encode it through the shared encoder, and supervise the structural information of the reconstructed image to improve the model's ability to extract the features of vehicles. Secondly, the natural language description of vehicles can be easily obtained from various vehicle websites. Therefore, we introduce a semantic prior module to better explore advanced semantic guidance from the perspective of multimodal pre-training to improve vehicle reconstruction. Combining these two modules, we design a vehicle pre-training framework, which we call VehicleMAE. Next, we present the experimental results. We validate our pre-trained model on 4 downstream tasks: vehicle attribute recognition, re-identification, fine-grained recognition, and component segmentation. We compare our model with our baseline and other state-of-the-art models on each downstream task. The results are shown in Table 1. Compared to existing general pre-trained models, such as MoCOV3, Dino, IBOT, and MA, our model performs better on all 4 vehicle downstream tasks. These experimental results and comparisons fully verify the effectiveness of our proposed vehicle-based pre-training strategy. In order to verify the effectiveness of our pre-trained VehicleMAE for tasks with fewer training samples, we use 10% and 20% of the training data in the downstream tasks for validation. The results are shown in Table 4. It is worth noting that our pre-trained model can maintain good performance even with only 10% of the training data. For the structural prior module and semantic prior module proposed by us, ablation experiments have been conducted on 4 downstream tasks, and the results are shown in Table 2. These experimental results fully verify the effectiveness of the structural prior and semantic prior proposed by us. In order to verify the influence of masking rate on pre-trained models, we set 4 different masking ratios, namely 0.25, 0.50, 0.75, and 0.85, and the results are shown in Table 3. The experimental results of the 4 downstream tasks indicate that a masking ratio of 75% can achieve better performance. We visualized the feature maps of MA in our VehicleMAE model as shown in the figure. We provided 4 images of 4 cars on 4 downstream tasks. Compared with our baseline MA, we can see that the heat map in key areas is higher, so our model performs better on vehicle perception tasks. At the same time, we also visualized the masked reconstruction images. As shown in the figure, the 3rd and 4th rows are the reconstructed images of MA and VehicleMAE respectively. Due to the structural and semantic prior information, the reconstruction effect of our model on vehicle structure is significantly better than that of the MA model as shown by the red bounding box. Finally, our contribution. First of all, we proposed the first multimodal pre-training framework for vehicle-centric perception, termed VehicleMAE. The structural counter information and high-level semantic prior are proposed for a more accurate mask token reconstruction. Secondly, we propose a large-scale dataset to boost the research of pre-training on vehicle images, termed Autobot 1M. It contains a total of 1M images and part of them with a corresponding language description. Lastly, we conduct extensive experiments on 4 downstream tasks to validate the effectiveness of our proposed VehicleMAE. We have related all the data set, source code, pre-trained models on our GitHub. Thanks for your attention.